welcome to our channel Knowledge of Friends. Subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your chemistry for class 12th, and that's being the class is your 32th class, and hopefully if it is not exceeded an hour or the limited time, so yes, of course, we will be sure to complete that in this class only. Before starting with this, it's a huge request from my side to all the viewers to please go through the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Other than chemistry, we talk about in the terms of chemistry, we had done your unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8 as well, and even the unit 9 here. We had completed that. In respect towards the units, we had completed your atomic numbers as well as symbols, molar masses, and their the elements name as well. After that, we talk about you had done your conversions as well. Today we'll start discussing about the logarithms as well. So that is being the important one as well, and that will be we have to talk about it. In terms of logarithms, here sometimes a numerical expression that may be involve multiplication, divisions, or rational powers, or for that is of the large numbers. For such calculations, logarithms are very useful. They help us in making a difficult calculations easy, and in chemistry, logarithm values are required in solving the problems of chemical kinetics, thermodynamics, and electrochemistry, etc. We shall first introduce this concept and discuss the laws which will have to be allowed in working with logarithms, and then apply this technique to a numbers of problems to show how it makes difficult that the calculation simple as well. On the same behalf of it, we just discussed that we know that 2 to power 2 is your 8 here, so sorry, 2 to power 3 is 8 because 2 2s are 4, 4 2s are 8 here. So 3 to power 2 is of course 9, 5 to power 3 is 125, 7 to power 0 is 1, that we know very well. And according to that, in general, for the positive real numbers a and a rational number that may be a of that we have is equals to b, so where b to a, b is a real number. In other words, we can say that m of that power of base is a is b here. And on the same cases, m of ab is, it means the powers we have ab, so that is the powers here as well, and m is the base here. So another way of stating the same fact is logarithm of b to base a is m here. If for a positive real number a, and that is a is not equals to 1, the name a to power m is equals to b. We say that m is a logarithm of b is the base n, and we write this for the log b of a, that is equals to m here. Log being an abbreviator of the word logarithm, thus we have here, so we'll just write it on some of the values that we have in respect towards the log 1. So we'll go ahead for the same values. We have log 2 base a, it is your 3, log 3 9 is equals to 2, where log 125 by 5 is equals to 3, and log 0 log 7 1 is equals to 0. Since in this we know very well that 2 cube is equals to 8, 3 square is equals to 9, and 5 cube equals to 125, and 7 power 0 is equals to 1, even though which we had discussed here itself. After, other than that of the logarithm, we talk about it, and that is being about your the law of logarithms. In terms of law of logarithm, here we talk about it, that what even we have to discuss about it. So here, for in the following discussion, we shall take the logarithm to any base a, and for a is greater than 0 and a is does not equals to 1. For the first law, that is being the log a mn is equals to log a of m plus log a of n. So we go ahead with the proving for the same here. So what it first law states that log of mn equals to log am plus log an here. So we have to prove that. So for the same we have here is for proving, suppose that log am equals to x and log an equals to y. Okay, suppose log a of m is equals to x, log a of n equals to y. On to the same cases here for this, that is we have, so then a you have your, then we can say that a की power x is equals to m and a की power y equals to n, and hence mn equals to a की power x, a की power y equals to a की power x plus y. It now follows from the definitions of logarithm that log a of mn equals to x plus y equals to log of a m minus log of a n here. That is being we have, it has been even represented here as well. So we'll talk about the second law here for the same sake. That is being the second law that we have to write it down. Second law, second law we have is log a m by n is equals to log a m minus log a n here. So all the same cases we have to solve it out as well. So that is being the important test here, even though which we have to talk about it. So that is being represented. Then proof for the same, a of x is equals to m, a of y equals to n, hence m upon n equals to a of x upon a of y is equals to a x minus y. So therefore log a of m by n, that is equals to x minus y, that is equals to log of a m minus log of a n. We'll talk about the third law here, that what we have to talk about it. So we'll discuss about here third law. So in terms of it, that is being the log a of m power n is equals to n log a n here, n log m. So proof we have here, that is being asked before, if log of a m is equals to x and a की power x equals to m, then m की power n is equals to a की power x upon n equals to a की power n x. So giving log a m की power n is equals to nx and log a m here, that we have here. Okay, so for the same we have to talk about it. Thus, according to the first law, the log of the product of two numbers is equals to the sum of their, that is being the logs here. Similarly, the second law says that the log of the ratio of two numbers is the difference of their logs, and thus the use of these laws converts the problems of multiplication division into the problems of addition, subtraction, which are far easier to perform than multiplication, division, and that is why the logarithms are so useful in all numerical computations as well. We'll discuss about the another one, which is your logarithm to base 10. Logarithm to base 10. That what we have to discuss here. In same cases for this we have your, because the number 10 in the base of the writing 10 numbers, it is very convenient to use logarithm to the base 10. Some examples that we have to discuss here, which is in the form of log 10. 10 is equals to 1, since 10 to the power 1 is equals to 1. Log 10 100 equals to 2, since 10 to the power 2 is 100. Log 10 10,000, that we have is equals to 4. 10 to the power 4 is equals to 10,000. Log 10 0.01 is equals to minus 2. It is 10 to the power minus 2 is equals to 0.01. Talk about next. Log 10 0.001 is equals to minus 3. So since 10 to the power minus 3 is equals to 0.001, and log 10 1 equals to 0, since 10 to the power 0 is equals to 1 here. So in the same cases, the above results indicate that if n is an integral power of 10, that is one allowed by several zeros, or one preceded by the several zeros immediately to the right of the decimal point, and then log n can be easily found. If n is not an integral power of 10, then it is not easy to calculate log n, but the mathematicians have made tables from which we can read off approximately the value of the logarithms of any positive numbers between 1 to 10, and these are sufficient for us to calculate the logarithms of any numbers that is expressed in decimal form. For this purpose, we always express the given decimal as the product of the integral power of 10 and a number of and the number between 1 and 10 as well. Now we'll discuss about the standard forms of decimal here. Standard form of decimals. So here in this, we can express any number in decimal form as the product of an integral power of 10, and that a number between 1 and 10. Here are some examples. We'll talk about some of the questions that we have to deal with it, that is being representing here. The first being representing is 25.2 lies between 10 and 100. 25.2 equals to 25.2 upon 10 into 10, which is equals to 2.52 into 10 to the power 1. Next question we have 1038.4 lies between 1000 and 10,000. So 1038.4 to 1038.4 upon 1000 into 10 to the power 3, it will be equals to 1.0384 into 10 to the power 3 here. Go ahead. Another question is your 0.005 lies between 0.001 and 0.01. So for the same, that has been representing here, 0.005 is equals to 0.005 into 1000, which is equals to 10 to the power minus 3, multiply as well, and that's equals to 5.0 into 10 to the power minus 3. Next we'll go ahead with another question that we have to talk about it, is being your 0.00025 lies between 0.0001 and 0.001. For the same, 0.00025, and that is equals to 0.00025 multiply 10,000 into 10 to the power minus 4 equals to 2.5 into 10 to the power minus 4 here. Now we'll go ahead with another question that what we have to talk about it, and that has been the important question as well, and that has been here. For in each cases we divide or multiply the decimal by a power of 10 to bring one non-zero digit to the left of the decimal point, and do the reverse operation by the same power of 10 indicated separately. Thus any positive decimal can be written in the form n into n is equals to m into 10 to the power of p, where p being the integers will be positive, 0 or negative, and 1 m is less than equals to 1, m is greater than equals to 1 and less than 10 here. So this is also called a standard form of n here. So we'll talk about the working rule for the same. In terms of working rule we talk about it. So yes, for the working rule, that move the decimal point to the left or to the right as may be necessary to bring one non-zero digit to the left of the decimal point. And so the second step, it will be that if you move p places to the left, multiply by 10 to the power p, and if you move p places to the right, multiply by p per 10 to the power minus p, and if you do not move the decimal point at all, multiply by 10 to the power p and write the new decimal obtained by the power of 10 of step 2 to obtain the standard form of the given decimals here. Now we'll discuss about some of the characteristics of mantissa. Characteristics of mantissa. In the same, that you have to consider the standard form of n, where being n equals to your m into 10 to the power p, where m is, as I told you, is being greater than equals to 1 or 2 less than equals to 10. Taking logarithm to the base 10 by using the form laws of logarithm here. Log n equals to log m plus log 10 to the power p, log m plus p log 10 to p plus log m here. Okay, so here p is an integer, and that is being so 0, or that log n is less than equals to your 0 to greater than, that is being greater than equals to 0, and of course less than 1. So that is being m lies between 0 and 1, and when log n has been expressed as p plus log m, where p is an integer, then 0 or log m is less than 1. So we say that p is characteristics of log n, and that log m is a mantissa of log n. And note that the characteristics is always an affine to the characteristic integers, positive, negative or 0, and mantissa is never negative and always less than 1. If we can find the characteristics of the mantissa of log n, we have to just add them to get the log n here. So thus on the same cases, that thus to find the log n, all we have to do is to be as follows, like put n in the standard form, that says, and which is being in the form of n equals to m into 10 to the power p, 1 is less than 10 here. You have to read off the characteristics p of log n, and from this expansions here, and then exponents of 10, and look up log m from the table which is being explained below, and write log n equals to p plus log m. If the characteristics of p of a number n is says that 2 and the mantissa is 4, that is your 0.4133, then we have log n equals to 2 plus 0.4133, which we can write as 2.4133, and it, if however the characteristics of p of a number m is at say minus 2 and the mantissa is 0.4123, then we have log m equals to minus 2 plus 0.4123. We cannot write this as minus 2.4123. Why? In order to avoid the confusion, we can write the 2 bar for minus 2, and thus we can write it down like m equals to 2 bar 0.4133 here. So on the same cases here, that note, now let us explain how to use the table logarithm to find the mantis, and a table of being that appended it will be here. And on the same cases, you have to observe that every row of the status that is in the 10, from that 10 11 12 to 97 19 99 here, that every differences which have 9 columns headed by 1 2 9 here only. On the same cases, we are now, or suppose we will wish to find out 0.6.234, then you have to look that, and you have a log 6.230 will be is of course equals to 0.7945 approximate. A log 6.234 is being equals to 0.7948, and that has been taken here. So we'll have to find out the value for n when log n is given here. On the same cases, we have to go ahead here and do the same. So here, for the same we talk about it, and we'll have to find the n when log n is given here. And on the same cases, finding n when log n is given. So on the same cases, we have to find out here, and that is really important too. So here with the same cases, we have so far discussed that the procedures for finding log n when a positive numbers is being given, and we now turn to its converse, that is to find the n when log n is given, and that give a method for this purpose. And if log n equals to t, we sometimes say n equals to antilog t, then therefore our task is to be given here t, and find its antilog. For this, and we have to ready for made antilog tables as well. Suppose log n is equals to 2.2, we have, I just write it down for you all. Log n is equals to 2.5372, To find n, first take just the mantissa of log n, and in this case it is 0.5572 here, and on that now take up the antilog of this number m, that the antilog table which is to be used, and exactly the same for the log table. In antilog table, the entity under the column 7 in the row 0.53 is 3.3443, and that mean difference for the last digit 2 in that row is 2 here, and so that the table given is 3445, and hence antilog we have here for the same antilog 0.5372 is equals to 3.445. So now since log n is equals to 2.5372, the characteristics of log 6 is 2, so that the standard form of n is given here, and that is being equals to m equals to 3.445 into 10 to the power 2, or n equals to 344.5 here. So illustration, we'll do it the questions here that for the same, and that what even though we have to talk about it, so we'll go ahead for the same as well. So we'll go ahead for first solving it out. If log x is equals to x equals to 1.0712, then find x here. So for the solution, we find that the number that corresponding to 0.0712 here, or is 1179, since the characteristics of log x is 1. So we have here is being solution we have here is for the same x equals to 1.179 into 10 to the power 1 is equals to 11.79 here. We'll talk about the another questions here, which is the next. We'll talk about it, that is in the illustration. If log x is equals to 2 bar 0.1352, find x. So for the same we have to talk about it, and that is the solutions here. From antilog table, we find that the numbers corresponding to the 91352 is 1366. Then the characteristics is 2, that is minus 2, 2 bar, that is minus 2. So x equals to 1.366 into 10 to the power minus 2, and that is being equals to 0.01366 here. Now we'll go ahead with another question that use logarithms and numerical calculations as well. Use of logarithm in numerical calculation. That we have. For the same, we have to talk about the question is being as follows: is find 6.3 into 1.29. Let's solve it out. So here let x equals to 6.3 into 1.29, then log x equals to log 6.3 into 1.29 equals to log 6.3 is equals to log 1.29 that we have, and now log 6.3 is equals to 0.7993, log 1.29 is equals to 0.1106, where log x equals to 0.9099 here. That will be the right answer for this, and we are taking the antilog both side, we'll get x equals to 8.127. that we find it out. Now we talk about the another question, and that is being the another important one as well. So on the same behalf of it, we have to discuss here. The question is, find 1.33 over 1.5 upon 1.2 into 23.5. So we'll go ahead for the solution for the same. So let x equals to 1.23 to power 3 by 2 upon 1.2 11.2 into 23.5. Then log x is equals to log 1.23 power 3 by 2 upon 11.2 into 23.5, that is being equals to 3 by 2 log 1.23 minus log 11.2 into 23.5 that we have here. Now the same cases, now we have log 1.23 equals to 0.0899, that is being 3 by 2. We have your 3 by 2 log 1.23 is equals to 0.13465. Log 11.2 is equals to 1.0492. Log 23.5 equals to 1.3711, and log x is equals to 0.12485 minus 1.0492, that is being equals to 3 bar 0.71455 here. That is also being minus your 1.3711. So we'll get the value of x is equals to 0.005183. That we have to talk about it, and that is being the important one as well. We'll go ahead for the next question. We will talk about in same cases, that is being the important one as well, and that is we have to find out. This has been the last as well, and other than that we have to talk about the logs and antilogs as well. The question being as follows is, find under root 71.24 to the power 5 into under root 56 whole upon 2.3 to the power 7 into under root 21. So we go ahead, let x is equals to 71.24 power 5 into under root 56 whole upon 2.3 to the power 7 into under root 21, where then log x is equals to 1 upon 2 log 71.24 to the power 5 into under root 56 whole upon 2.3 to the power 7 into under root 21, that we have. After that we'll have your 1 by 2 log 71 over 24 power 5 plus log under root 56 minus log 2.3 to the power 7 minus log under root 21, which is equals to 5 by 2 log 71.24 plus 1 upon 4 log 56 minus 7 by 2 log 2.3 and minus 1 upon 4 log 21. Then we'll now using the log table here. So log 71.24 is equals to 1.8527, log 56 is equals to 1.7482. Then we have log 2.3 is equals to 0.3617, and log 21 is equals to 1.3222 here. Therefore log x equals to 5 by 2 log 1.8527 plus 1 by 4, 1.7482 minus n by 2, 0.3617 minus 1.4, 1.3222 here. That is being equals to 3.4723, and x is equals to 2967 here. That will be the right answer for this question as well, and that has been the important one here too. And on the same behalf of it, as you know that we are dealing, there are many there are table for log and for antilog here, and that what you have to solve it out. So here we had end up with chemistry of part 1 NCRT for that is being important for competition as well as for the academic as well. Other than that, we talk about it. We had done your sociology and software engineering, and after talking about that, we had done your we are dealing with the quantitative aptitude. In terms of quantitative aptitude, we had started with arithmetical ability. We had completed operations on numbers, SCF and LCM of numbers, decimal fraction, simplification, square roots and cube roots, decimal fraction, and pumps on numbers, pumps on ages, surds and indices that we are dealing here. And after that, we had completed the sociology and software engineering. We are dealing with the DBMS, where we are dealing with different types of diagrams. That is being the important one as well. After talking about that, we are dealing with the reasoning here, which has been divided into two sections, which is verbal reasoning and non-verbal reasoning. In verbal reasoning, we had completed your the mental ability and the logic reasoning. In non-verbal reasoning, we had done series and logic classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, door detection, grouping of identical figures, cubes and dice that we are dealing here right now. Other than that, we talk about in terms of chemistry. We had completed in unit 1, which is the solid state. We had completed general characteristics of solid state, amorphous and crystalline solid, classification of crystalline solid, crystal matters and unit cell, numbers of atoms in a unit cell, Rosberg structures, cycling efficiency, calculations involving unit cells, dimensions, imperfections in solid, electrical properties, magnetic properties as well. Unit 2 is your solution. We had covered up your types of solution, expressing the concentration of solution, solubility, vapor pressure of liquid solution, ideal and non-ideal solution, colligative property, and the determinations of molar masses and noble molar masses as well. In unit 3, which is electrochemistry, we had completed electrochemical cells, galvanic cells, Gauss equation, conductance of electrolytic solution, electrolytic cells and electrolysis, batteries, fuel cells, corrosion as well. Unit 4 is your chemical kinetic, where we had completed the rate of the chemical reaction, factor influencing the rate of the reaction, integrated rate equation, pseudo first order reaction, temperature dependence on the rate of the reaction, collision theory of the chemical reaction as well. Unit 5, which is surface chemistry, where we had completed your adsorption, catalysts, collides, classification of collides, emulsion, collide around us. Unit 6 is general municipal and processes of isolations of element, where we had completed occurrence of metal, concentrations of ores, extractions of fluid metal from concentrated ore, thermodynamic principles of metallurgy, electrochemical principles of metallurgy, oxidation, reduction, refining, uses of aluminum, copper, zinc, and iron. Unit 7 is the P block element, where we had completed your the group 15 elements here. In the same case, for the group 15 element, we had completed the dinitrogen, ammonium, oxides of nitrogen, nitric acid, phosphorus, allotropic form, phosphine, phosphorus halides, also acids of phosphorus, group 16 element, dioxygen, simple oxides, ozone, sulfur, allotropic form, sulfur dioxide, also acids of sulfur, sulfuric acid, sulfur element, chlorine, hydrogen chloride, and also exits of halogens, interhalogens compound, group 18 element as well. In unit 8, we had covered up your DNF block element, where we had computed the positions in the periodic table, electronic configurations of D block element, general properties of the transition element of D block, some important compounds of transition element, the lanthanoid, actinide, some application of DNF block element as well. In group unit 9, we had done the coordination compound, which is the one theory of the coordination compound, definition of some important terms pertaining to the coordination compound, nomenclature of coordination compound, isomerism in the coordination compound, bonding in the coordination compound, bonding in the metal carbon analysis, stability of the coordination compound, importance and application of the coordination compound as well. So that's what we had end up with, and it's a huge request to all the viewers to please go through with the subscribe button and please like, share and subscribe our channel so that many maximum people can get the information at once, and when you can also enjoy the video as well. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.